insights from the first commits. Distributed nature. The first commits in Git showcase its distributed nature, which is a core feature. Unlike centralized version control systems, VCS, like SVN or CVS, Git allows each developer to have a complete copy of the repository, including its history. This makes Git more flexible, scalable, and resilient to failures. Early commits emphasized this decentralization. 1. Handling of branches and merges. The early commits of Git reveal its powerful support for branching and merging, which are core to how modern Git workflows operate. Git's branching model is one of the system's defining features. Branches are lightweight, making it easy to experiment with changes without affecting the main line of development, usually referred to as master or main. In Git's first commits, you can observe that this was designed from the beginning to be a central aspect of the tool. Merging was also a focal point. Git's approach to merging, using an algorithm that minimizes conflicts and uses three-way merges, ancestor, local, and remote versions, ensures that collaboration remains as smooth as possible, even when multiple developers are working on the same codebase simultaneously. This early focus on solving the merging and branching problem reflects Git's deep understanding of software development workflows. In the first commits, you can find the roots of this merging capability, which was particularly important for a project as massive as the Linux kernel. Git was designed to allow large teams to contribute to the same codebase with minimal friction, supporting parallel development streams. 2. Immutable history and data integrity. Another key feature emphasized in the early commits of Git is immutable history. The commit hash, SHA-1, guarantees the integrity of each change by making it computationally impossible to alter a commit without detection. This cryptographic structure means that each commit has a unique identifier based on its contents, ensuring that the history is tamper-proof. This emphasis on data integrity can be seen as a security-first design principle, rooted in the need for a version control system that could handle contributions from many different developers. By making the commit history unchangeable, Git guarantees the authenticity of the entire history of the repository. For the Linux kernel, where many contributors might submit patches, this design ensures that the record of changes is trustable and auditable. The hashing mechanism also reduces the risk of accidental errors in version history, since any manipulation of a commit would require recalculating all subsequent hashes. This brings peace of mind to developers, knowing that the commit history is protected from simple mistakes or intentional malfeasance. 3. Encouraging collaboration. One of the overarching principles of Git that emerges from its early commits is collaboration. While many version control systems focused on keeping track of changes by individual developers, Git's model emphasizes team interaction. This is reflected in the design of Git's repository structure, which can efficiently support multiple contributors, and in the fact that each developer working with Git has the entire history of the project locally available. The early commits reveal that Git was designed to facilitate asynchronous collaboration, enabling developers to work independently and later synchronize their work. Features such as pull requests, originally known as merge requests in GitHub and GitLab, and distributed branching workflows were designed with collaboration in mind. This allows teams to experiment, iterate, and improve code quickly without waiting for a centralized server to approve or store changes. 4. Performance and scalability. Git was designed to handle very large repositories, like the Linux kernel, which has millions of lines of code, efficiently. The system's ability to scale to massive repositories without a significant drop in performance is a key feature that emerges in its first commits. The performance was a central concern for Torvalds when designing Git. The ability to work with large codebases and many contributors without slowing down or using too many resources shows the system's focus on high performance. The decision to track changes as snapshots rather than diffs, as other version control systems did, significantly improved the speed of operations, as it eliminated the need to constantly compute differences between file versions. By leveraging an efficient internal model that uses objects, blobs, trees, commits, Git reduces the overhead typically associated with handling large repositories. Compression and deduplication of file content were also core to Git's early design, which made the tool efficient in terms of both storage and network usage. These elements are visible in the initial commits, showing an early emphasis on efficiency. 5. Open source design. Git's open-source nature was also evident from the beginning. The initial commits were driven by Torvald's desire to create a tool that would be open and available to anyone who needed it. This reflects the Linux kernel's own open-source ethos and is critical to understanding Git's design philosophy. The system was meant to be transparent, modifiable, and extendable by anyone who wished to use or improve it. Git's open-source community quickly grew, and its design was refined by developers all over the world. Even in the early commits, Git was designed to be a tool that could be embraced, modified, and improved by the community, a feature that distinguishes it from proprietary version control systems. Conclusion: the true meaning of Git, when revealed through its first commits, encompasses several intertwined principles. Collaboration: Git was built to make it easy for multiple developers to work on the same codebase independently, supporting distributed workflows and enabling efficient merging. Data integrity: Git ensures the immutability of commit history and protects against tampering, reinforcing trust in its version tracking. Efficiency and scalability: Git's design prioritizes performance, with the system optimized for both large repositories and multiple contributors. Security: through cryptographic hashes, Git guarantees the integrity and authenticity of every change, protecting developers from malicious changes or accidental errors. Open source: Git was designed from the start to be an open, flexible, and community-driven tool, enabling anyone to use, modify, and extend it. These foundational principles found in the early commits shape the modern Git system that has become the backbone of collaborative software development. Through these choices, Torvalds created not just a tool for version control but a system that empowers developers with freedom, security, and performance.